solve these questions. And now let's move on to question number 11. But before we do that, just a quick little water break. Okay. Well, I can still read it out. We have, right, what is a balanced equation for the reaction between acetic acid and sodium hydroxide? So, acetic acid and sodium hydroxide. And we want the balanced chemical equation. So first thing, we want to be able to identify that sodium hydroxide, okay, is a strong base because it has hydroxide in it. So that's NaOH. So with that, the separate formula for it is going to be Na plus OH minus. Whoops. NaOH turns into Na plus OH minus, okay? So now acetic acid, right, is going to be CH3 COOH. And I know that acetic acid is not a strong acid, but to be able to find out for sure, we actually have the acids and bases list here. And acetic acid is all the way down here, a weak acid. So we usually denote by this formula of CH3COH plus water. Okay. The key thing here is this arrow, because there's not a complete association. It can go back and forth till we have CH3COO minus plus H3O plus. Okay. And now for the last part, if these two are going to dissociate like that, then we see that the products formed are OH minus and H3O plus. And as you can see here, hydronium ions, they work pretty good in terms of, I guess, being a strong acid. But the goal here is that when we have this, we lead to 2H2O. So then together, what we're left with is Na plus OH minus plus CH3CO COOH. That would go into CH3COO minus, and the Na plus would form this, and then we have plus, because it has, oh, I almost forgot, plus H2O is the last part, because we still need that water, and there'll be 2H2O. But because we have H2O and 2H2O on each side, we can actually cancel out one H2O, because that was the one from here, and this right here would be our completed formula for acetic acid reacting with sodium hydroxide. Na plus H2O, the CH3COH plus NaOH, CH3COO plus H2O. And exactly, this is going to be the balanced chemical equation, because as you can see, 1 to 1, OH, H3O, and then we're able to cancel out one of the waters. So this would be our formula, and this is correct. And the only reason why I have the Na and the OH separate is just because for strong bases, when they are put in water, they do just dissociate completely. And if we were assuming that this was put in like an aqueous solution, this is what we would actually be working with. So that's how the Na can now be attacked by the CH3COO minus, and the H proton, that was just taken away by the OH minus. Okay. And now for question number 12.